For this homework video guide, we will continue to evaluate the following limits. And for question number 1, this limit is approaching 9. So if we apply a direct substitution step, we will get 0 over 0. All right, so we need a brand new algebraic step to kind of solve this particular problem. And since we have a radical on the numerator here, a very good strategy is to multiply by the conjugate here. So the conjugate in this case will be root x plus 3. And then we also need to mathematically times the denominator by root x plus 3. Okay, so let's go ahead and simplify this. So I have the limit as x approaches 9. Now, what I generally tell students is that you'll notice that on the denominator, I have x minus 9, and I'm multiplying that with root x plus 3. So that's not the conjugate, right? So what we're going to do is we're just going to attach those two pieces together as x minus 9 in a bracket, and then we'll multiply that by root x plus 3. So we're just going to leave it alone just like that. Okay, what we're going to do here is now we're going to move on to the numerator, and the numerator represents the conjugate, right? So we can definitely multiply this out, and root x times root x is going to be positive x. And then when we're multiplying by the conjugate, the second and third terms always cancel out. So then all you have to do now is you take your negative 3 and times by your positive 3. So negative 3 times positive 3 is going to be negative 9. And that's how the conjugate works. The second and third terms in the FOIL step always cancel out so that you only need to multiply by the first and last terms. And then you'll notice that the x minus 9 and the x minus 9s will cancel out. So now you have the limit as x approaches 9. So there's a 1 on the numerator, and on the denominator there's an x plus 3. And now we can apply a direct substitution step here. And if we do that, I get 1 over the square root of 9 plus 3, which is going to be 1 over 3 plus 3, which is going to be 1 over 6. All right, so it's very important that you're very comfortable with multiplying by the conjugate. All right, let's take a look at another limit problem here. So there is a radical on the numerator here, right? So once we see that, chances are we definitely need to apply by the conjugate. And the conjugate of the numerator is going to be root x plus 2. And then since there's a minus sign here, we're going to times by positive 2. Okay, so that's our conjugate right there. So now we have x plus 2 on the denominator and then plus 2. All right, so that is the strategy that we will be using for this particular problem here. So let me put a bracket there and there, and on the next step here, let me write out the limit statement. The limit as x approaches 2. Now, once again, if I look at the denominator here, I have x minus 2, and I will multiply it by root x plus 2 plus 2. So that's definitely not a conjugate, right? So let's just, the non-conjugate part, we'll just park that on the denominator as is. So root x plus 2, and then plus 2. All right, so we're not going to distribute or anything. We're just going to leave the two pieces next to each other. Now let's go ahead and multiply the numerator, because the numerator represents the conjugate part, right? So I have root x plus 2 times by root x plus 2. So if I multiply this by this, the same radical times the same radical is going to be just x plus 2. All right, so that's the first part of FOIL, the first term and the first term. And then because it's a conjugate, we just take the last term and the last term, right? So if I take this negative 2 and times it by a positive 2, I get negative 4. Okay, so that's what I have there, right? Now, because I'm creating a homework video guide, I can cheat a little bit here. I have a plus 2 and a negative 4, right? So plus 2 minus 4 is going to be negative 2. So if I erase that, I get x minus 2 on the numerator there. And now you'll see that this x minus 2 and this x minus 2, that can essentially just factor out or cancel out. So I'll erase that and I'll erase that. And that means there's just a 1 on the numerator, right? So if I just clean this up here, I have this now, and I'll just transfer my limit sign over here like this. Okay, so when you're doing your homework, you might have to write a few multiple steps there to kind of get to this step here. Now what I'll do now is I'll complete a direct substitution step. So if I do that, there's a 1 on the numerator, and on the denominator I have the square root of 1 plus, sorry, not 1, but 2 plus 2. So 2 plus 2 and then plus 2. And then I have 1 over, well, I have the square root of 4 plus 2, and that's going to be 1 over 2 plus 2, which is 1 over 4. Okay, so that's my answer for that particular limit problem. All right, let's move on to the next one here. All right, so very similar problem here. I have a radical on the numerator there. So once I see this part right here, the numerator, I can multiply by the conjugate, which is x plus the square root of x plus 3. And then on the denominator, I can multiply by 2 plus the square root of x plus 3. So when I multiply the top and bottom by the same thing, mathematically, I haven't changed the original problem, right? So all these steps are mathematically correct. So I have the limit as x approaches 1. Now let's go ahead and just simplify the denominator first. There's an x, sorry, not simplify, but on the denominator there's an x minus 1. And since we're not dealing with the conjugate, we'll just attach this piece right here as 2 plus the square root of x plus 3. And then extend that line. And then let's go ahead and multiply the numerator there. So using FOIL here, 2 times 2 is going to be 4, right? And then if I just erase this part here, and if I highlight just this part here, the minus sign, and if I multiply that by that, right, so a negative times a positive means that the negative sign will win. And then root x plus 3 times root x plus 3 will just be a single x plus 3 in brackets like that. And once again, if you I can cheat a little bit here because let me just kind of simplify the numerator here, right? So this is mathematically correct. So let me kind of simplify the numerator here on the side. If I distribute that, I get a 4 and then a minus x and then a minus 3, right? So if I distribute that minus sign, that's what we get. And then if I keep on simplifying here, I have a negative x and then a plus. So 4 minus 3 is going to be plus 1, right? And then if I factor out the minus sign here, I can get x minus 1. Okay, so if I just erase the numerator here, what really survives, if I simplify the numerator, I get negative bracket x minus 1, right? So I can kind of cheat like that using a tablet pen here, and then I'll notice that this part and this part simply just cancel off, right? So now I can cancel that off and cancel that off, and then on the numerator, there's just a minus 1, right? And then I can just copy the limit sign a little bit closer here, the limit as x approaches 1. Alright, so that's what I have here, and this is looking pretty good. Now I can apply a direct substitution step into that x there, and if we do this, we get a negative 1 all over 2 plus the square root of 1 plus 3, and that will give me negative 1 all over 2 plus the square root of 4, which is negative 1 over 2 plus 2, and I get negative 1 over 4 as a final answer there. Okay, let's move on to another one of these multiplying by a conjugate problems here. And for question number 7, this one, you'll notice that there's a radical on the numerator and a radical on the denominator there. So what we're going to do is we're going to multiply by the conjugate twice. So this one's a little bit different here. So let me see if I can, let's go ahead and multiply by the conjugate of the numerator first. So that's going to be the square root of x plus 1. And then I have a plus 2. And I'll put that in a bracket. And then on the denominator, I'm multiplying by the square root of x plus 1 and then plus 2. Okay, so that's step number 1. And then step number 2 is that we notice that there is another radical on that denominator, on the denominator that we have, and we need to multiply by the conjugate of that. So if I do that, let's go ahead and open up another brackets here. So this will be the square root of x minus 2, and that will be plus 1. And then on the denominator, I'm multiplying by root x minus 2 and then plus 1. Alright, so kind of a weird problem here because we're multiplying by the conjugate 2 times. And we've got to be very careful with our algebra steps here. Okay, let's go ahead and see if we can multiply this by this. Okay, so if I multiply that by that, this one's not too bad. We're just going to be very careful here. So this times this is going to be just x plus 1. All right, and then if I multiply the negative 2 by the positive 2, I get negative 4. Okay, and then what I'll do next is, okay, this is going to be a bit tricky here, but that's done. And after that, okay, so let me erase this because I'm done with that. And then what we'll do next is I have this part right here in green. and I'll multiply it with this conjugate over here. Okay, so and if I continue, actually let me just see if I can just simplify this very carefully here. So this part here in blue, that's just still going to be this part over here, which is root x minus 2, and then the plus 1. All right, so I'll write my limit sign over here. Okay, and then what we're going to do now is we're simply just going to multiply the green with the green. So if I multiply this with that, so root x minus 2 times root x minus 2 is going to be just x minus 2. And then if I go ahead and just multiply this -1 with this positive 1, I get a -1 there. Okay, so then I'll put that in a bracket. And then technically I'm kind of done with this now. And then I still have this blue part here, right? So I'll put that blue part just underneath here. Park that down there. So that's going to be bracket root x plus 1 and then the plus 2. Okay, so that was a bit complicated, but we managed to get all of that. All right, so now what we're going to do now is we're going to simplify this part right here. So if I do that on the side here, or on the bottom here, this is really x plus 1 minus 4, which is really x minus 3, right? So I can erase this now and replace that with just x minus 3. And then let's take a look at this part right here. That's really x minus 2 and then minus 1, which is really x minus 3, right? So if I erase that, I get just x minus 3. Okay. And then you'll notice that the top and bottom here are the same, so we can just kind of cancel that off and that off. And then I can erase this. And then I'm just left with that now. And then I can write my limit sign like this, which is x approaches 3. And then now we're looking pretty good here. And now we can apply a direct substitution step here. And if we apply the direct substitution step, we get 3 minus 2 plus 1 all over the square root of 3 plus 1 plus 2. Okay, so this will be the square root of 1 plus 1, all divided by the square root of 4 plus 2, which is really 2 divided by, well, that's going to be 2, so 2 plus 2 is 4, which is going to be 1/2. Okay, so after all that, we do get 1/2 as a final answer there. All right, so hopefully that example was okay. We're just kind of multiplying by the conjugate twice there, so just try that question one more time if you weren't able to follow all the steps there. Okay, now if I move on to the second part of the video here, we're now finished the basic conjugate problems, and if I take a look at the next few homework questions here, these are the kind of the fractional kind of questions here where we need to clean things up. And for this particular question here, I'm definitely going to use the smiley face method here to kind of simplify things. So let me kind of start off by writing the limit sign. The limit is h approaches 0 here. And so what I'm going to do here is I see a 9 here, and I'm going to multiply that with the 1. So 1 times 9 is going to be a 9, and then there's a minus sign. And then I'm going to take this h plus 3 squared, and I'll multiply with that -1. So if I do that, I get bracket h plus 3 bracket squared. And then the next step in the smiley face method is that you take that step and that step, so those two terms, and you multiply them together to get the happy face there. And then if I do that, there's the 9 times h plus 3 all squared. Now, this next part, please don't just write this in your notes just yet, but we're still dividing by the h, right? And in class, you might remember me saying things something like, if I have a half, and if I divide it by 3, this is really the same thing as 1 divided by 3 times 2, which is 6, right? So this h can really just come up there and just multiply the whole thing with h, right? So if I just erase all this, I'll just write a times h right there. And then you'll notice that we've actually really cleaned up this little fractional piece by a lot. Okay, so let's go ahead now, go ahead and continue to write the limit sign here. The limit is h goes to 0. There's a 9 here, so 9 minus, and let's go ahead and just double square that. So that's going to be h squared plus 6h plus 9. And then on the denominator here, actually what I would like to do is that this h right here, which I'm highlighting, let me just kind of bring that and multiply with the 9. So 9 times h is going to be 9h. And then I have a bracket h plus 3 all squared. Okay, great. So now we're going to just distribute that minus sign on the numerator there. So this will be 9 minus h squared, and then minus 6h, and then minus the 9, all divided by 9h bracket h plus 3 all squared. And then we have the limit sign here, the limit as h goes to 0. Okay, so I see that this and this cancel off. So let me just kind of erase that. And let's take a look at this expression right here. So what can I do there? Well, we can factor out the negative h, right? So if I factor out the negative h, I get h plus 6. Right, h plus 6. And let me see if I erase this now, I can replace this now with, replace this now with a negative, and then the h, bracket h plus 6. Alright, so I can do that, and then notice that this h and this h, they just kind of cancel off, right? So this and this cancel off, and I'll just go ahead and write another step here. So minus bracket h plus 6, all divided by the 9, and then the bracket h plus 3 all squared, and we still have our limit as h goes to 0 here. So quite a bit of algebra in this particular problem here, right? So now we can do a direct substitution here. The 0 there, the 0 there. If we go ahead and plug in 0 there, I get bracket 0 plus 6 on the numerator. On the denominator, the 9 still survives, but then I have a 0 plus 3 all squared. And then on the numerator there, we have a negative 6 divided by 9 times, well, 3 squared is 9. So this will be negative 6 all over 81. So negative 6 over 81 is totally fine. If you want to keep on simplifying, I guess that's going to be negative 2 over 27. So negative 2 over 27 is your final answer for that question. Okay, let's keep on going with these fractional questions here. So I'll try to speed it up if I can. So there's a 3 here. So 3 times 1 is going to be 3. And then if I have a root x, if I times that with negative 1, I have negative root x. And then the next step in the smiley face method is that you take these two terms and you multiply them. So that's going to be 3 times root x, which is 3 root x. And then we have our limit sign here as x approaches 9. And this is technically divided by x minus 9, right? And if you remember, this is exactly the same thing as 1/2 divided by 3. So if I have a fraction divided by a number, those two numbers can just multiply, give me 1 over 6. So I can move this up here. And I can move this up here and just multiply by x minus 9. Extend that bracket, and then this is what we have now. Okay, great. So we have so far, and let me just kind of clean up the top here. This is just 3 minus root x. Okay, perfect. Now we're back to one of those radical questions from the start of this homework video guide, and since I have a radical on the numerator right there, the best way to kind of get rid of that is by multiplying by the conjugate, right? So I can multiply the top and bottom by 3 plus root x and the denominator by 3 plus root x. Okay, so let me write a limit sign here, the limit as x goes to 9. Okay, now the denominator, I'm just going to keep the denominator completely the same, so 3 root x, and then I have an x minus 9, and the non-conjugate piece we just leave alone and just attach it. Okay, all right, and now we just do a FOIL step on the numerator there, so 3 times 3 is going to be 9, and since this is a conjugate, the second and third terms cancel, so all you have to do now is take your last term, which is negative root x, times positive root x, which is going to be negative x. Okay, now let's go ahead and take a look at the numerator here, right? The 9 minus x. All right, well, if I look at that, that's the same thing as negative x plus 9 if I rearrange it. Then if I factor out the minus sign, I get negative bracket x minus 9. All right, so in the numerator here, I can simply write this as a negative sign and then bracket x minus 9. Okay. And one of the reasons why I do that is because you'll notice that this part and this part will now cancel off. So my next step, I have the limit as x approaches 9. Okay, so I have a 3 root x. And this one and that one will cancel off, giving you a -1 on the top. And on the bottom, there's a 3 plus root x. Okay, and finally, we can now do a direct substitution step here. So there's a -1 on the numerator. On the bottom, I have 3 times the square root of 9, bracket 3 plus the square root of 9. And let's go ahead and see if we can simplify this. This is -1 over 3 times 3. And then we have a bracket onto 3 plus 3. So lots of weird, these calculations too, they're not trivial, so make sure that you do take your time on these. So 3 times 3 is 9, times 3 plus 3 is 6, so final answer is -1 over 54. Okay, so that's the final answer for that question there, and we'll definitely finish off this homework video guide by doing one more complicated algebra question here. And I believe we have this one here to finish off. So I see a square root x plus 2 and x squared minus 4. A lot of things going on here. So I'll start by circling the 2 over there. And if I apply the smiley face method there, 1 times 2 is going to be 2 minus, and then there's a root x plus 2, and that's multiplied with the -1. So that's going to be the square root of x plus 2 with a minus sign there. And then we can just multiply the bottom terms there. So 2 times the square root of x plus 2 attached. And then we'll write the limit sign over here with the x approaching 2. And we've done this a few times here with this x squared minus 4. We can just kind of attach that with everything else, right? So if I had to extend this line here and put brackets around that, I can put a bracket with the x squared minus 4 there. So that looks pretty good there. And what I'm noticing here is we have a radical. There's a radical on the numerator again. So this means we need to times by the conjugate again. So the conjugate of 2 minus the square root of x plus 2 is going to be 2 plus the square root of x plus 2. And 2 plus the square root of x plus 2. So let's put that in a bracket there, and let's go ahead and we can simplify this. Okay, so we have a big mess on the denominator there, so we'll keep that mess together. So let's just go ahead and clump everything together here. So I'll say, I guess this part right here, I know we're probably going to factor that as a difference of squares there. So x plus 2 and x minus 2. And then this green part we'll leave as 2 plus the square root of x plus 2. Okay. And now we'll multiply the conjugate part on the numerator there. So if I multiply positive 2 by positive 2, I get a 4. And then we know the second and third terms cancel off. And then we'll have this, this whole thing, this negative root x plus 2 times positive root x plus 2, which will be negative bracket x plus 2. Okay. So just by looking at this, we probably need to clean up the numerator, cancel something out, and go to a direct substitution step, and then we'll be good. Let's go ahead and take a look at the numerator here. So I will look at the numerator on the bottom here. So this is the numerator, and I'm just going to do a side calculation here on the bottom. If I distribute that, I get 4 minus x minus 2, and this equals to negative x plus 2. And then we can factor out the minus sign as negative bracket x minus 2. Okay. So what does that really mean now? I can erase the numerator, and I can replace that with a negative sign, bracket x minus 2. Okay. And once we do all that, we notice that there's an x minus 2 and x minus 2. Those can cancel off. So if I write one more limit statement here, I guess on the numerator there's a minus 1 that survives. On the denominator, there's a 2 square root of x plus 2. And then there's a single x plus 2 in red. And then we have all this green stuff here, which is 2 plus the square root of x plus 2. Okay, so very long here. And even doing a direct substitution step at the very end here is also very taxing. So if we go ahead and finish off a final direct substitution step here, I get 2 times the square root of 2 plus 2, which is 4. And then bracket, if I plug in a 2 in there, I get 2 plus 2, which is 4. And then 2 plus the square root of 2 plus 2, which is 4 again. Okay, so we're almost there here. So one more line here, a line or two here. Okay, so now we have, 2 times the square root of 4. So that's 2 times 2, which is going to be 4. And then we have another 4. And then 2 plus 2 here, right? So 2 plus 2 is also going to be another 4, right? So our final answer is going to be negative 1 over 4 times 4 times 4, which is negative 1 over 64. Okay, so a lot of questions that were covered in that homework video guide, and hopefully these steps will help you complete your homework.